Welcome to video on 2.6, which is called Proof Statements about Segments and Angles. So we're going to be doing more proofs. I'm going to do the warm-ups with you guys. I'm going to definitely do 2.6.1 and 2.6.2 and even 2.6.3. Well, kind of. I'm going to give you a little bit of a push and have you do 2.6.3 on your own. For the first page, for sure, I'm going to do all of it. So remember we talked about properties of qualities in the previous video on 2.5. So if measure of angle 1 equals measure of angle 3, then measure of angle 3 equals measure of angle 1. Well, duh. And remember, we call that the symmetric property for angles. AB equals CB, CD equals TU. That's a typo. That should be CB. Then AB equals TU. And we're going to call that transitive property for qualities. Oh, sorry, transitive property of quality for angles. And then here, if RS equals WX, I don't know. Oh, then you're adding something to both sides. Got it. Okay. WX plus AB. So you're adding AB to both sides. Got it. I was a little thrown for a loop there. We call that the addition property of equality because you're adding the same thing to both sides. Okay, so hopefully doesn't seem too bad. So just some review from last time. So here, a logical argument shows a statement is true. That's what a proof is. A proof is a logical argument that shows a statement is true. So first we're going to talk it out, but then we're going to write a two-column proof where we have statements and reasons, just like we had in the 2.5 notes where we have these equations we're solving and we stated each step and then the reason for that step, like if we added some of both sides or subtracting a number from both sides. So let's talk this out first. AB equals CD, okay. Let me get a highlighter out here. So that is the same as that. And you're asked to prove that AC equals BD. Well, that kind of makes sense, right? I mean, for example, what if this had a length of 4 and this had a length of 4? And of course, let's say BC, I want to say of course, but we'll say BC is 10. So I'm making these numbers up. These are totally made up numbers. Well, yeah, of course, AC is going to be 14. And of course, BD is also going to be 14. Of course, they're going to be the same, right? So you always want to talk these out first, just to make sure you see the logic that goes into it. But then you actually have to write it formally. This is the part that sometimes can be the most painful part of geometry. If you talk to anyone who's taken the class and you mention proofs, their eyes will bulge out of their heads. I'm going to try and make this as painless as possible. But it's an important part of math because you do want to have strong logical reasoning. And this is what we're trying to do. We're trying to build up your logical reasoning so that when you do move forward in math, like in Algebra 2 or pre-calculus, or if you do calculus in at Christian Brothers or in college, that you have the logical reasoning skills to be successful down the road. So we're trying to train you guys to be better thinkers. That's really what, I mean, are you ever going to use this stuff in real life? No. But are you going to have to think logically in the real world, depending on your profession? Yeah, absolutely. If you're a doctor, a lawyer, if you happen to be in business, sales, definitely, yeah, you have to think logically and try to come up with proper steps to do your job. So that's what we're just trying to teach you to be better thinkers, right? So first off, what are we given? AB equals CD, right? Not that hard. That's given. Always that those are 3 points. State that. So this is what you're given, right? Now we want to prove this. If we think about it, BC, we could add AB, right? AB plus BC equals AC. We know that, right? And remember that was a segment addition postulate. We had that in chapter 1, I believe. So you have to use old stuff. I abbreviate SAP. And I'm going to combine, I'm also going to say this as well in the same step. BC plus CD equals BD because they're both the same reason, right? They're both SAP. Then I'm going to say this. AB, I'll put this in green here, plus BC equals CD plus BC. And that's the addition property of equality. Because I added, what I've done is I added something to both sides of the first step. Added BC to both sides of those. And of course, step 2 is using a diagram. So sometimes they also like to say what these refer to. So obviously I had to use step 1. I won't make you guys do this, but I've seen some geometry teachers what did they refer to? So for the second step, refer to the diagram. For the third step, refer to step 1. So then lastly, for step 4, or statement 4, well, AB plus BC is right there. BC plus CD is right there. So naturally, we can say AC has to equal BD now, because AC is that, and BD is that. And when you do that, we call that substitution. Substitution, property of equality. Ultimately, you don't have to write the property of equality all the time. You could just say, actually, just say substitution property. You can say substitution or addition property. That's fine. And obviously, we referenced step 3 here. So we use a previous step to get us to the next step, right? That's how proofs work. That's a logical flow. So we were given statement 1. Statement 2 we use for the diagram to help us make that conclusion. For step 3, I used step 1, where I added the same thing to both sides of the equation. And then step 4, I used step 3 and step 2 also to make that conclusion. So that's a proof. And you'll need some time to kind of let this sink in a little bit. Let's look at another one here. This one's a little more interesting. So 5 friends are hanging out discussing their favorite jewelry. They find that each one has a different favorite and use the clues to find everyone's favorite piece of jewelry. Okay. So Rose's favorite jewelry starts with the same letter as her first name. So definitely not that one, definitely not that one, definitely not that one, and definitely not that one. It's got to be that one there. Kaylin does not like gold or opal. So Kaylin does not like gold or opal. Okay. It's kind of like Wordle. If you guys play Wordle, you have to eliminate words. I just did it this morning. Took me a little while. Tina's grandmother gave her diamonds for her birthday because they are Tina's favorite. Oh, and she likes diamonds. Well, that was easy. Okay, little check mark there. We X out these right here. And by the way, the ruby belongs to Jenny. Sorry, the ruby belongs to Rose. So you can put X's here as well. And the diamond belongs to Tina. So you can put X's here as well. So now we're narrowing this down pretty nicely, right? But we still need another clue. Because, for example, the gold could belong to Jenny or Vicky. The silver could belong to Jenny, Kaylin, or actually, we've now narrowed down what Kaylin has to be. She's definitely silver. So see how nice this table is. So I can X out these here. So now it's down to just Jenny and Vicky. So Jenny and Vicky either like gold or opal. Jenny's favorite jewelry is either gold or silver. Well, silver belongs to somebody else, so she's gonna be gold. Therefore, Vicky's gonna be opal. And there you go. So we use the clues correctly to match the jewelry with the right person. So again, this is a logical flow. You're gonna do something kind of similar here. And then I'm gonna write a 2-column proof. So 4 women went to the supermarket, they bought different items, but each one forgot to buy something. Find out how much each one spent and who forgot to buy bread. Okay, so Angela forgot to buy detergent. Sorry, Angelica forgot to buy detergent. So you're gonna put a check mark actually, because you want to figure out what they forgot to buy, because they bought different items, but each one forgot to buy something. So Angelica forgot detergent. So you're gonna put X's here and here. And then you have more clues to kind of figure out down below. So you're going to do the same thing we did in the previous example. And then I guess what we're trying to figure out is, don't worry about writing a 2-column proof for this. This seems a little weird to me to write 2-column proof. Don't worry about that. We could do that together. That just seems a little strange to have you do on your own. All I want you to do is just fill out the table for 2.6.3, and then you'll be done with this video. And we can go over that later in class. So fill out 2.6.3. Okay, I'll stop this video.